Okay, so in general, the decentralization of Starknet is also through the protocol decentralization, and in the future decentralization of every entity in the process of creating the block, the sequencer, the prover, and the state update. But we also in the process of decentralize the development, the process of Starknet, meaning we want to transform the core design and core developer from Starkware, what it was in the beginning of Starknet, to the entire community through the process of SNIP, the EIP of Starknet, right? The Starknet improvement proposal. So we've started to do it with a SNP for transaction v3. This is the first core SNP talking about protocol change in Starknet. And the next that we want to do is the Volition SNP, meaning the Volition feature that will be included in one of the next major Starknet versions that we'll talk about in a minute. We want to do it more openly. We want to involve the community in the design discussions about the SNP, and every involvement is valuable. Okay, so this is like a general disclosure about the workshop, and we encourage you to participate in the community forum and suggest your own design, etc. As for Volition, we'll go a little bit about, we'll give a little bit background about what is Volition, why it's needed, what is the design that we are have in mind at the moment that we've started to implement, and then we'll go over a little bit more of a tricky part of the design, what happened after L2DA crisis and how the governance and the consensus can recover from it. And then eventually, if we'll have enough time, we'll try to understand how should we design the ERC20 under Volition. Okay, so what is Volition in general? What is Volition in general? Volition at the moment, like 95% of the average transaction cost in Starknet is for data availability cost of L1. Every storage cell that we update on Starknet will be posted on L1 as call data for the transaction. The computation became much smaller thanks to validity rollup and validity proof, but the L2 data availability remains, L1 data availability remains expensive as it is in Ethereum. So let's say transfer in Ethereum is about $5, depends on the gas prices, but currently it's about $5. In Starknet it will be 0.5, but almost 95% of this half a dollar going to L1 data availability update. Okay, so what we want, how can we solve it? What can we do to reduce the cost of data availability? What we had in mind is having an additional data availability mode, which won't be posted on L1. Only the commitment to this data availability mode will be posted on Ethereum, but the data availability itself will be only part of the L2 blocks. Okay, we'll soon draw a little bit the state of Starknet and how the commitment look like, but this is the general idea. Having some of the data availability, some of the storage posted only on L2 blocks, meaning that the cost for data availability will be much cheaper. If we have the commitment, the state of Starknet consists of the classes, the contract classes, and the instances of the classes and their storage. We can basically think of it as two trees, one for the declared contracts, all the new contracts that added to Starknet, and one will be the tree of the instances of all the contracts that are actually being used. Okay? Every contract that every contract, we can think of it also, it's actually also a tree for his storage, right? It could have storage, the storage is also a tree, the commitment for the storage of a specific contract is also a tree. So in general, the state of Starknet consists of two trees, the declared contract and the deployed contract. I'll draw only the deployed contract. Okay, so let's say each one of the leaves here is a contract in the contract state. The state of Starknet, as we said before, is the hash of both the.
Can you write what's like?
Yeah. This is the deployed contract, hash of the deployed contract, and this is the declared contract. Is it clear? Okay. And this is the state commitment for the state of Starknet. Each one of the leaves here is a contract in the Starknet state. Okay. Every contract has its own storage, so it's another Patricia tree. Okay. It's the same for all contracts. Now, if I do an update in a specific storage cell, what will be posted in L1 will be the cell that changed, the root contract, the address of the contract, and the number of the changes, and the root of the whole tree. Okay. This is the current situation. In the design that we are suggesting, we'll have an additional tree. We'll have two trees for data availability. In each, we'll have all the deployed contracts. So the structure of if we said that the tree of deployed contract is tree of trees, because each contract is another tree, the structure of the tree will be the same in the L1 data availability mode and in the L2 data availability mode. Okay? Let's say this is contract with the address 1x, the address 1. This will be also the same contract in the same address. Okay. Now, if the contract and the storage of the contract, volition means that I will have the ability as a developer to choose whether to update the storage in this tree. And in this tree, as we said before, we'll post everything on L1. If we'll change this storage cell, we post it on L1 and the root of the contract and the root of the entire tree. While in the other data availability mode, in the L2 data availability mode, we'll post on L1 only the changes of the root, and the changes of the storage inside the contract will post only as part of the L2 block and not in the L2 or not in the L1 data availability. Is it clear or?
So in this drawing, the left one is the L2 tree.
The left one is the L1 data availability mode, and this is the L2DA. Okay, in both trees we have the exact same address, and every contract can have storage in both trees. Okay, and I can choose as a developer for every contract whether to update it in the L1 DA or to update it in the L2 DA. I can have storage variables in this tree and in this tree. The difference between them is that updating the storage variables in this tree is much cheaper than updating the storage variables in this tree.
Could you have an arbitrary number of copies of the tree? Like, could you have Ethereum DA, Starknet DA, Eigen DA?
Yes, 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 yes. This is the. This is.
What are you saying?
There are other modular data availability layers, so like Starknet could build their own, like, or they could use, like, you know, someone could choose to use a different layer.
Yes, this is the plan. We plan to have in the future a lot of data availability modes, but the first version will consist only one additional data availability mode, the L2 data availability mode. Yes.
But construction of these trees, it's not guaranteed that there's not a collision between the L1DA leaf and the L2DA leaf, right?
You want collision. You may want.
You want them to stay in sync, like not exactly.
No, they should have, the L2 data should only have the L2. Oh, will it have the entire storage space?
Yes.
For, it's not the,
it's not
merging.
splitting of the storage space. This is a completely.
Yes.
Won't the roots be the same?
It probably won't be the same, but it could be the same if the storage was exactly the same storage. If I would save everything here, both in everything in every contract, both in the L2DA and in the L1DA, maybe the root will be the same, but it doesn't matter. I post both roots on L1.
If I set a value in the first block to L1 and I send it to L1 and I set that value to 10. And the next block I set that value to 20 but on L2.
You'll have in the same address,
Yeah,
you'll
same
have
address, same storage key.
yeah, the same storage key. Let's say the key is 1 again, and here it's the value is 10, and here the value is 20. It's possible. And it's
So how do you provide? Does that not make storage proofs impossible?
Or do you need a node?
no, why?
How do I prove to someone what the latest value of that storage key?
You need
also separate keys. Think of you have a storage pool for the L1 state domain, and you have a different storage pool for the L2 state domain.
So storage proofs will now be.
you'll need to specify the data availability mode that you are referring to.
Do you like sync it every once in a while? Just like the
You have to sync it manually as a contract.
To think what? You may want to sync it, and you may want to choose not to sync it. For example, we'll talk at the end about ERC20 design, but one of the possibilities is to have two balances mapping, one in the L1DA and one in the L2DA. And I want to allow you to have, for example, in one of the design proposals, to have balance in the L2DA and in the L1DA, and to have different balances in each.
From each contract perspective, you now have a two-dimensional key for the storage.
Yes, and actually you already have those when you in Tier 1 when you do storage read and writes, you specify the other domain.
Yeah, but the address domain is
It's
entirely
always-
taken by 250 bits, whatever, 12 bits of all on L1. But now we have felt, felt, and the first felt decides which, in some sense,
We already have it, we just always use 0 for the first one, and it's not the first, it's 8 bits that specify UAs.
I think it's 32. Yes.
One smart contract, but you're pulling data from, you pull it from layer one, it could be in the variables can have some values, but if you pull it from a relationship variables.
Yes. When you read or write from the contract, you need to specify what is the data availability mode that you want to read or write for. And yes, okay. For example, the ERC20. Okay, one of the design again is will allow you to have L1DA balance and L2DA balance. Why would you want this? Because the L1DA is more safe. We'll talk about it in a bit. And the L2DA, as we said already, is much cheaper. So I would prefer to pay the fees with the L2DA, right? Because it's cheaper to update the balance. Sorry?
So the balance is on L1. And then
Let's say I have 100 ETH. I would want to save 99 of them on the balance that's stored on L1 DA because it's safer, and I will want to store 1 ETH on the L2 DA because it's cheaper to pay from it and to what?
Long-term storage.
Yes.
Accounts and,
Yes,
I
exactly.
was confused. I thought you could put 99 here, sorry, 100 here, 100 there.
I would need yes.
The deployer, that developer can allow users to choose which data availability is used for specific user.
Sorry.
So, for example, 100 users.
Yes.
So it means the user can choose which availability is used for the portfolio. Is it correct?
Yes, the developer, the choice is of the developer, and the developer can choose to give it to the users, right? I think that makes sense. Design a reasonable design for ERC20 will give the users the choice where to store their balance.
Would this decision be like baked into a wallet, or maybe there's a default based on like a value per bit, like you can override it?
Yes, there are two things that every user will be able to choose for himself. We'll talk a little bit about it. But as for the balance and the ERC20, it's not yet decided. There is no concrete design for the ERC20. We'll share with you the thought that we have, but it's not closed yet.
Okay, cool.
Okay, so another thing that is, yes? Sure.
Maybe this is a crazy, stupid question, but like, let's replace the balance with an NFT.
Okay.
Now the NFT is just copied.
It won't be a copy. You need to decide where you want to store it. You can at first think of it as a huge storage. You can store it wherever you want, and then you need to decide whether the storage you'll commit to it on the L1 DA or in the L2 DA.
Each storage key basically gets an additional bit.
Yes,
And if the bit is 0, it goes to L1. If the bit is
exactly.
1, then it goes to L2.
You can write it twice if you want as a developer, but you can write it twice also in the L1 DA. If you want to write something in the storage twice, you can do it, right?
You can duplicate it.
Well, you can duplicate it the same way you can write the same value to multiple storage
Yes.
addresses. But I mean,
if you imagine the code, let's say you mint an NFT, you can do one write operation to have it stored in the L1DA. So there's a storage slot that contains this JPEG encoding on the left side, but on the right, the value at the same key is 0. If you really want to, you can store again. Probably don't want to, but this depends on your NFT logic.
That means there's two NFTs now.
No. If you choose to do it, which would be weird, that's why you won't do it.
I think the idea is if you wanted to move it from the left tree to the right tree, it would almost be like bridging. Like conceptually, like you have the same structure in each tree, if I'm understanding
Yes.
correctly, but like the asset is only in one of them. Like one of them is just known by default, but you can move something, if you have the 100 each, you can move one from here to there. Like you're taking it out of the left tree to put it in the
yeah,
right
I don't think you can physically copy the NFT. The NFT contract would let you transfer.
Yeah, it would like you would bridge from this contract to its clone contract in the other tree.
Just copying the data doesn't replicate it. It's the interpretation of that data that assigns its value. So if I have if I just copy 100 in both fields, doesn't mean I want to eat. Because if in the ERC20 contract does that, it just copies 100 and tries to pay 100, then it's unsound ERC20 contract. You shouldn't use it.
There are two levels here. One is the design and how the storage and the commitment to the state look behind the scene. And the other one is the implementation level. And it's we need to decide, after we decide on the general design and how the state look like and what we commit to, we need to decide how to define the ERC 721, right? And we can decide that in the design of the ERC 721, you can store it in both or in one of the two. it depends on what we'll choose to implement there. I think that it's more reasonable for NFT, unlike ERC20, to store it only in one place. You'll have to choose whether your NFT is here or here. Okay, and it makes sense that if you have cheap NFTs for gaming, you'll store it on the L2DA. And if you have some asset that worth millions of dollars, you'll store it on the L1DA. Okay, but this is a different level of design.
I mean, the NFT could choose to store on both. It just needs to make sure when it doesn't transfer, that both are changed. Or if one of them is lost in, then it like sets it to 0 or null or something like that. Otherwise, the NFT contract is unsigned.
Two more interesting properties of the design before we'll go to the risks. One, the nonce. We said that we have the exact same address in both trees, right? The nonce of account contract is in the leaf level in the contract address triplet. Actually, the definition of leaf in the contract tree is a commitment to the storage, which is commitment to another tree. The address, the class hash of the contract, and the nonce. The nonce is actually also duplicated. We can use nonce both in the L2DA and in the L1DA. The nonce meant to guarantee the uniqueness of transaction. This is why we need to advance it every time. In the new design, what will happen is that you'll be allowed to use whatever nonce you want. If you want to advance the L2DA nonce, you can choose to use this nonce. And if you want to advance the L1DA nonce, you can choose to advance it. Why it's a nice feature? Because it will, the reasonable behavior is to always choose to advance the L2DA nonce because it's much cheaper. And if there is any kind of a crisis that we'll go over in a minute, you can always choose to use the L1DA nonce and going back to use this nonce, so your account will always be available for you. So this is one additional feature which is in the protocol level. Another feature in the protocol level before we'll go to implementation of standards like the ERC20 is the DA mode for fees. You'll be able. We don't yet have the design for the ERC20, but we want this design to allow us use both L2DA and L1DA. So in the protocol level, when you submit the transaction, you'll be able to choose not only from where to take the nonce, but also from where to take the fees. So if you have funds in the L2DA, you'll be able to pay the transaction fee through this balance. So this is, in general, the design of the Volition and the feature that we want to add. Again, in the version, the first major version in Starknet that will include the Volition, it will be only one additional data availability tree and not multiple trees. Yes?
So you said that you want to have an ERC20 standard which can take fees from either L1DA
Yes.
or L2DA, but before the user being specifying which data to take from, they will need to bridge some of their ETH or some of their token holdings or some of the balance number from one DA to the other, right?
Yes. Yes.
And it needs to be like sound, like it makes sure that sum stays the.
If the ERC20 allows you to duplicate, then it's better.
Wait, you say duplicate is better?
It's bad.
Oh, bad.
Yes. So it's can sound.
Printing money.
Almost like what governments do from time to time. Okay, so cool design, give freedom to users and developers, give us the ability to have much cheaper transactions. We could go from $0.50 for transfer to less than 5 cents for a transaction, which is really cool. But now what are the risks? What are the risks? The risk is the lack of ability to reconstruct the L2 data availability. How it could happen in the decentralized world. Let's imagine that we have a malicious majority. Majority of the sequencer are malicious and colluding, and they decide to have even one transfer, one change in the data availability, in the L2 data availability mode, that they are not sharing with all other sequencer and full nodes. What will happen in that case? After the malicious majority attack will finish, the honest sequencer won't be able to update and to change the L2 data availability mode. Right? Is it clear? They won't have the data needed to reconstruct and to compute the new route. Okay? This is actually very scary situation. I don't think it's very probable, but it could happen. It's less secure than Ethereum, and in this case, it's not that only the L2 data availability won't be accessible, but the sequencer will be exposed to an attack that, for example, do a lot of changes in the L1DA, a lot of computation, and only in the end of the transaction, it calls to the L2DA. What will happen? The sequencer won't able not to execute the transaction and not to prove failure because it's not invalid, it just don't have the data. And this is a problematic situation. Okay. Also, let's imagine honest contract that use both L2DA and L1DA. Once we have malicious majority attack after the L2DA crisis, after the malicious majority attack, the sequencer won't be able to execute transaction using this contract because whenever it try to access the L2DA mode, it will fail. Okay, so this is our biggest concern from this design. At the moment, what we are thinking about once we have a data availability crisis is by governance decision to decide to create a new data availability tree. It will have the same name, but if at the moment we specify DA mode 1 in read-write syscall when we try to access storage here, from now on we'll need to specify 2. Whenever a transaction specify DA mode equal 1, the transaction will fail. It will be possible to prove failure because it will be added to the OS. The transaction with DA mode 1 is okay to revert, yes. And whenever a contract that was already deployed and it tried to get to DA mode 1, the OS and the sequencer will switch it or redirect it to the new data availability mode. So in practice, what will happen? Every transaction will need, we won't be able to do replay attack because we can't just resend transaction with non-zero and L2DA DA mode equal 1 because those transactions will fail. We need to use a different DA mode. And every contract that we're using the L2DA will have, once in the first time we'll try to fetch data from the L2DA tree, it will get 0 because it will be a new tree completely. So those are our current thoughts about how to recover from L2DA crisis. In practice, it means that if you develop the contract safely, you will only lose all the assets you have in the L2DA, but the contract won't be unusable anymore.
What if someone is able to give a tree that matches the L2DA rule?
What do you mean?
So let's say some outside, let's say some full node
Yes.
is able to give, like the sequence is glued or like just even all crash or whatever, but some full node is able to, it's not like technically proposed or validated for the network.
Even in this current proposal, even let's say my contract is unfair, the malicious majority touch some different parts of the state, even if you have all the state of your contract, and it won't don't have. Yes, you can use this information to execute transactions to your contract, but eventually it can't be proved because I can't create the numerical paths to the new rules because I'm missing some information. So that means if we have any hope of the contract functioning in the future.
If you have the data on a full node to entire tree, so it's not a data availability crisis. Just pass the data to the sequencer and everything will be good. The problem is
I don't have the, but I mean, you develop this part of protocol.
Email them.
Yeah, exactly. Then how do I send it to the sequencer?
Oh, you talk to them directly. No, for real. Like personally go to them.
yes, it will all
It will be a governance decision to zero
yes.
So I was going to ask that, is there, like, how does that work? Is it network upgrade or how do you flip that switch?
How do you sorry come again?
Reset the L to reset the L2 data availability.
How will the governance process will look like?
Yeah, because you have to bake that in our rate.
I think it won't. It's a great question. We don't yet have the timeline for recovery from L2 data availability crisis, but in my opinion, it will take day or two. You need to have a governance decision, meaning at the moment, for example, for the governance the decision to upgrade Starknet to version 11 or to version 12 was a governance decision, and the vote took a few days. So maybe you could rush up the vote, but I don't see how you can vote in less than 24 hours.
That's fine, but will this not cause issues with, like, because there's the other time limit on our one proofs, right? Which is if the proofs expire or take too long, then you can fork Starknet.
You can't fork.
So if the
L2, they
data,
already updated L1. They haven't updated L1, the malicious group of the sequences. Then we're okay because
no, what I mean is, so they update L1, and then there's the crisis. And the crisis, to resolve that crisis takes so long that it triggers the L1 fork condition.
But the error fork condition will also be only a valid state transition.
Yes, you won't be able to. If you could submit valid state transition, everything is good.
Yeah, well, okay, so somehow 5 nodes manage to take over.
Yes.
They twiddle, they drop, they screw up L2DA.
Yes.
You can't, the honest majority gets power back with the demo, and then they now can't prove things to L1.
Mm-hmm.
But the
They can prove.
the dishonest minority just sits there waiting for that timer to expire and then takes over Starknet completely.
No, they still need to.
But they have the trees, they're just not giving them to you.
Okay, so they will submit a valid proof for state transition. It's okay, because everything they could submit is a valid state transition.
Yeah. No. So
You still have the
they're
validity.
the only ones.
You-
But, so they can't now. Okay, so dishonest attacking minority
Yes.
somehow gets enough control to disrupt data availability.
Okay.
Now the honest majority regains consensus control.
Mm-hmm.
And while they have consensus, they don't let these attackers participate, right? But this minority has the full data required to make an actual proposed block.
They
So
can.
if they wait, if the fix takes so long that the L1,
so they do all state updates, no problem. But
All
in the
the-
meantime, there are Twitter discussions or whatever, and the social.
You have two things that I think you missed. One, even if they'll do say a state update, it's a valid state update. You still have the guarantee of validity. You just don't know the data, but the transaction is completely valid because if they can prove it, it's valid. One. Second, the honest majority will keep advance the L1DA state. The L1DA state won't stop because I have the entire. I just won't be able to execute transactions that are using the L2DA.
In your attack criteria, the honest majority condition is good. Assumption of network is good.
well, initially, maybe.
Even if it comes back. No, but if it comes back and if the 5 people are in the honest majority, then they would share the data with other nodes. They're not sharing it, they're not honest.
Yeah.
Yeah, it is a, that way.
Yes. So part of our concern about the L2DA crisis is more of a psychology concerns, right? Because I can build a safe contract that uses only the L1DA, but in blockchain you have a lot of composability. So maybe I'm using another contract that uses another contract and only one of them uses the L2DA in an unsafe way. In that case, L2D crisis might paralyze a big portion of the network. How big? We don't actually know. So the current plan is having much longer testnet time for this version with this feature. We usually have 2 weeks of testnet since of the last versions. We think that we'll need for this feature more than maybe more than 1 month, a few months, yes.
Can we have some VM guarantees that, let's say I have a ERC20 which is absolutely has to be in L1, or some contract which is all on L1, but I still want to compose with other contracts, and I say whenever I do a cross-contract call, I want to make sure all the three things that happen on L1 DA3. If they don't, I don't mind the call reverting.
Yes, it's a great question because this is one of the features that we want to add to the design. Maybe having some kind of decorator for the contract that enforce the contract to use only L1DA, and to add a syscall that can call. Yes, that you can pass him a contract address and ask, is it a pure contract that uses only L1DA? Yes.
Not just L1DA. Like maybe the call should be this function that I will call will only do changes to the L1 tree. I don't mind if some of its variables are on L2.
Maybe specifying, maybe adding data safe call, which fails, which reverts if at any point in time.
Or the other way around, I don't want my gas cost to be too high, so I want only L2 updates in this contract call. So
it's possible, I think.
I think that at the beginning, at least, we don't want to give too much power to the L2DA. So I don't want to encourage people to use too heavily the L2DA, because I think that people will use L2DA. And if most of the network will be on the L2DA, it might be a disaster once we have an L2DA crisis.
Another one that happens, similar to Espresso, and I think the full node network should like maybe do some more sharding, and because there should be a lot more full node nodes, and they have this protocol for like information dispersal where they start with centralized.
But full nodes don't help you in the case of malicious sequencers just not sharing the data to full nodes. It's like they have all the signatures in a click. They do zero networking, and they just create valid blocks which they can then pull.
In this case, there is like honest majority assumption is broken on the network. Right?
Yeah. In any case, nothing here works if there is no breaking of the honest majority assumption.
Yes, once the data went to full nodes, you're fine. You won't have the data availability crisis. The only option for data availability crisis is if the sequencer aren't sharing the data. Okay.
So yeah, we are talking about that. Yeah, sequencer is malicious. The case of the sequencer malicious, and they change the data on and to getting zero state. Sorry.
No, it's okay. It's okay.
My question. So, how can we get back by majority? Who is the majority and who is malicious? What is the difference?
If I understand correct.
Because the malicious people and the majority of stakers something are different. That's why we can recover. If these are same, so we cannot recover.
Are you asking what happened if
If the data ability is changed in malicious way, so what will happen
Okay.
to recover?
Okay, you're asking if the data will be changed by the malicious majority, what will happen?
Yeah.
Okay, so if the data was changed by the malicious majority, what the malicious majority will do is they won't share the data with other people. And if you don't have the data here, you cannot advance the state of this state. This is the problem, and this is the risk that we are having. Did I answer the question?
You don't have an immediate way to recover.
Yes, we don't have a way to decouple between those. Once it happens, we need to have a governance decision and to change the protocol, to change the code of the OS and the verifier.
You mean governance of Starknet?
Yes, the governance of...
Governance of DA, not governance of DA, governance of...
Yeah, of Starknet, yes. Yeah.
So it's a bigger
Yeah, you have to step outside the protocol, because the protocol is basically screwed now. Like you can't recover.
So you have to change the protocol, exactly.
Like L1 DA lets you recover this kind of attack because it's on L1, we're assuming L1 is secure. But if on L2, then the assumption flies out the window, so you need a way to recover, and the only way is a manual switch somewhere.
So a potential issue you were saying why this ERC20 needs to be built properly is if part of it is using L2 DA and part of it's using L1, and if L2 has a problem, you'll break the whole thing. That was what you suggested.
Yes.
Okay, so that's only relevant in this example we're talking about with this like enshrined L2 DA. So if in the future sometime like Celestia or something else was used, that wouldn't be relevant, right?
Yes,
It's only relevant for like this enshrined DA.
Yes, the L2DA is a unique one because it's based on the consensus of Starknet.
Okay.
So once we have an issue with the consensus with Starknet, we have it screwed the protocol in many ways. So we need to give it spatial treatment.
And that's the only reason you can even have this like hybridized DA like within a contract's functions.
What do you mean?
Because it's built into the protocol.
What do you mean?
Fetch from Celestia contract.
Yeah, okay. Yes, that's exactly what I was saying. How do I communicate that? The first thing I asked you about like this possible attack vector, if you have a contract, say the ERC20, that's touching both states, it's only possible because this DA is built in. It's like this is a strong reason to have an enshrined DA rather than just use some external solution like Celestia.
It's unclear exactly how to use an external. Yeah, can it? I feel like there needs to be some block delay, like I finish the block on Starknet, what can I immediately build, or what should I wait for the
Yeah.
consensus?
Okay, cool. Thank you.
There's only ever going to be one other CDA. There's not going to be more than one.
No, in the future we will have more than one additional DA, but we still need to understand, we don't have the clear design of how it will happen. Okay, for example, let's say that the third DA that I have is Celestia. I need to submit the state diff to Celestia, and then somehow I need to submit Ethereum a proof that the data availability was actually submitted to Celestia, right? Or if I had a data availability committee as the third data availability node, I need to submit Ethereum both the signatures of the data availability committee that they actually have the data. Okay, so in the future we will have these options, but it won't be in the first version of Volition. Yes?
If you do zero and out, do you think that... Sorry, I'm just thinking from a full node's perspective now, like how would that be communicated to them? Because like I imagine they're just going to get the state of every, because full nodes still have some history in their stuff, right?
Yes.
So they'll just get this massive state of zeroing out everything. Or how would that work?
After the data availability crisis?
Yeah, like you resolve
No,
it.
it will be a new tree.
Yeah, but how would the node do that?
Yeah, you need to.
Yeah, you'll need to update the RPC. No. You keep the old database and you'll need to add another tree that will start from zero.
You'll have to know which block to do that switch. That'll be different.
You won't need to switch, you just need to add another data availability mode. And in the state diff that
I see.
are
So
in the
you
block.
You can almost drop everything except the root for that one, so what you can have 3 roots.
Yes, exactly. And in the future you'll have much more than 3 roots.
So you're gonna have to put that one network as
Well, we hope it won't happen often at least.
Yeah, I know.
Or ever.
Yes. Okay, so I think we don't have a lot of time, but I do want to go quickly over the thoughts we have on ERC20. If you have any comments or thought about it, I'll be happy to talk about it later. So the 2 assumptions for design of the ERC20 is one, we don't want to break existing contracts that are using the API of the ERC20 for get balance, transfer, allowance, all of those methods. This is one. 2, we do want to give users the flexibility to have balance on the L2DA to give them the ability to cheaper transactions. Okay, so we have let's say 4 concepts for ERC20. The first one is maybe the most safest one, but the least flexible. In this idea, you have one contract of the ERC20 token, you have balance on the L1DA, you have balance on the L2DA, but every address can be only in one balance. You have balance or in the L1DA or in the L2DA. The pros of this design is that all the API methods of the ERC20 remain the same. When I ask balance off, I have a clear answer for this request because it's the entire balance and it's here or there. The biggest con of this suggestion is that you won't be able to pay, for example, to pay fees from the cheaper mode and to gain assets or to gain funds in the more safe mode. So if I want to pass you 100 ETH and you want to accept and I want to transfer it from my L1DA, I'll need to pay the fees also from the L1DA. So this is the disadvantage of this suggestion. You want to ask something?
I think I missed something. Did you say that the balance needs to be on both or on one?
Yes. In this design suggestion, this is the first one. We have like 3 more.
So we design a new token and it's like ERC20, L1 ERC20, L1 plus L2 ERC20, L2 ERC20?
No, you will have one contract for ERC20. Let's say Stark. We have Stark token. It's an ERC20 contract, and you have in the same contract you have balance that's stored on L1DA and balance stored on L2DA. By default, your balance will be on the L1DA, and then you'll be able to choose to move the transfer the funds you have to the L2DA, but your address will be only on one of the balances, here or there.
So you can move your entire balance?
Yes, in this suggestion. The rest of the proposals are, again, one contract, 2 balances, 1 in each, and every account can have balance in both trees, both L1DA balance and L2DA balance. But the question that we'll have, we need to answer to request in the regular API of the ERC20. We need to have the method to implement the method of get balance, get total supply, and transfer and everything else. So we need to decide what will be the default behavior of those methods, right? Yes?
If we allow any contract to have arbitrary use L1 and L2 at the same time, then even if we set an ERC20 standard which says all has to be one place, then developers still might not choose to
Of course, you don't have to implement ERC20, right? You can say I have a token, but it doesn't meet the requirement of ERC20. It's okay. You can do whatever you want.
Or it's a superset of ERC20.
What?
And then it says, when you say balance, it queries both L1 balance, L2 balance, sums it up.
Yes, exactly. This is one of the proposals we have. What is the disadvantage of your proposal? Once you have data availability crisis, this contract, it's not half, it won't be during the crisis, you won't be able to use this ERC20, right?
Get balance isn't working anymore, so basically wallets aren't working anymore.
But if we say that the L2 DAM is zeroed out,
Hmm?
But until
אתה רוצה שנפסיק?
It's not available at all. You can't, right? That even means you can't change either.
בוא נעצור, בסדר.
If you can't change either trade, you can't.
אני נקפל כאן.
but during the crisis I can't transact on it, but after the crisis is
5 דקות נסיים.
crisis, you can't even transact on the L1.
that way.
So,
But we could also say like that fetching from the L2 DA can like fail, and I can cache it, and then say if it doesn't return anything, just put 0 in there.
it won't fail because until you don't have the governance decision, maybe this specific sequencer don't have this data, but it doesn't mean that it fails. You can't prove that you try until the governance decision. Yes. So in short, the 3 suggestions for DRC20 in that case is the default mode will always be L1DA, meaning if I ask get balance, it will always take only my L1DA balance, and it will won't notice the L2DA balance, and will have another method in this contract that in those you will need to specify specifically what DA mode you are querying. Yes? Okay, sorry. Okay, so first one is the default mode is always the L1DA. Second is you can choose your own default mode. It will be L1DA, but you can switch your default mode to L2DA, and then when I'm querying get balance, it will fetch the balance from the L2DA. And
Switches the default.
yes,
Like who is choosing in this option 2 where the default could be switched? Who makes that decision?
the account.
Okay.
And the last option is return the sum of both options. Personally, I think that this is the most risky option because once you have data availability crisis, the ERC20 won't be accessible, and it seems risky to me. So I think that we are out of time, but those are our current thoughts about the ERC20 and the current plan for implementing the Volition feature. If you have any comments or thought or new idea, we'll be more than happy to hear them. You can reach out to us directly or post it in the community forum, and we'll be happy to talk and chat about it. Thank you.